So we are belongs to batch 27, and our title of the project is detecting the objects in a real-time visual media using deep learning techniques. And presented by Gudipadi Sriman Narayan Reddy, Gunnala Rakesh, and Gunnala Vignesh, and myself, supervised by Dr. R. Kavita, Professor. And here is your agenda for the minor project review. And coming to the agenda: abstract, objective, introduction, literature review, designing and methodologies, standards and policies used, implementation, testing, input and output, include demo video via YouTube URL, conclusion, future enhancements, and web references links, references, and plagiarism report of PPT and poster presentation. And next, coming to the abstract, object detection and object recognition are the most important things that play an important role in the development of enhancement of computer vision systems. And this is the main objective of our project. And the main key point in the object detection using images and video or webcam is efficiency and accuracy. The major challenge in many of the object detection algorithms used for computer vision system is slow, so that we come up with the YOLO algorithm, which is used for detection of object in accuracy manner. So we went through the YOLO algorithm, the approach of conventional neural networks, and that is CNN. And when compared to the other algorithms, YOLO V5 takes an entire, uh, which is very fast and accurate, and the final weights are required to obtain by training the dataset. And here are the few keywords: and object detection, object tracking, deep learning techniques, conventional neural networks, you only look once, that is YOLO algorithm, and bonding, box prediction, FPS, and computer vision. And coming to the objectives, this is the main aim of the project. The project aims to perform object classification, localization, and detection using deep learning techniques to have a good and accurate results. The major challenge in many of the object detection algorithms used for computer vision system is slow. To overcome this computer vision system, we come up with the YOLO algorithm, which we discussed in the previous slide, and it is overcome by using the deep learning based approach by conventional neural networks with YOLO algorithm. And next, coming to the scope of the project, in the object detection using YOLO could be broad and narrow depending on the application and available resources. You will need to decide which object classes you want your YOLO model to detect, how many objects are there in the screen, detect this simultaneously. You will also need to consider the hardware requirements, and the major problem in object classification, finding the particular objects present in the frame, and the input which we are giving in the form of GUI, which is graphical user interface, which can be better image or video or webcam. And a well-known application is face detection, used for detection dooriness and the driving vehicle. The computer vision falls under the field of artificial intelligence technology, and that deals with how computers can be made to understand the objects that are present in the digital images, videos, webcam based, etc. In the sample terms, computer vision seeks how to perform the task that human vision can do. The same way, the localization, real-time application that can be used under the object detection or lane detection systems. And here are the main both machine learning and deep learning techniques. In this project, the CNN method is used, which is the part of deep learning, and human learn and respond in different manners at the different times. And this is also same in the content in the introduction part of that minor project review. And here are the object detection is an important task in every computer vision that involves identifying or localizing objects within the image or video. Here, this is all the brief description of our introduction. And coming to the literature review, here are the few literature review we have gathered from around 9 10 literature review are there. And coming to the design and methodologies, and we classified into 3 modules. And first module, this is the first module, that is data collection. And the step 1, data collection and training using YOLO algorithm. We are using the COCO data set to get the output. And Step 2 is the processing of data object detection by continuously train on the bulk of data sets enables good prediction and localization results. And by using the data sets, and we are predicting the output by different approaches. And thereafter, the object detected is analyzed by comparing with parameter precision recall to know the robustness. And this is the module 2, that is object detection. After after this data collection, the object detection is technology that is used to detect the semantic objects present in digital images or videos. And as we discussed before, it is a fundamental problem in computer vision with many practical applications such as surveillance, self-driving cars, robotics, and augmented reality. And this is the object tracking after object detection. Um, this is the brief description of object tracking, and this is the steps-by-steps procedure by sequence process of approaching our project. Step 1, step 2, step 3, step 4. And coming to the module 3, steps to execute an implementation project. And step 1 is in this module 3, step 1 is the data preparation, and step 2 is training the YOLO algorithm. And coming to the step 3, testing the YOLO model. Here are the few points regarding the YOLO model testing, and the loading the pre-trained YOLO model and the pre-process the and runtime the images. Next, apply non-max suppression to remove the overlap buffers. Save or display the resulting images with object. This is the step 3 for the YOLO model. Here are the few standards and policies. Uh, Google Colab next one is standard used to ISO, IEC 27001 and 2013. Here are the personal computer. The specifications are you can see RAM of 4 GB, hard disk with 40 GB, and monitor shall be either any LCD or LED, a normal keyboard and webcam. It's Python, and these are the IDE which we are using for the implementation of our project. The version of the Python here is 3.7.0 being used in the project. And here the standard used ISO same. The Visual Studios, in Visual Studios we are using like IDE and Net Framework, Netcore, C++, Python, and many other languages. It is also integrated with the various development tools such as Git, Azure, and SQL Server standard user. And this is Darknet. It is a neural network framework. We also use Darknet for our project. It supports the computation with both CPU and GPU. It makes our project easy to implement by using this Darknet, and it can also compatible with Linux and Mac OS. Darknet follows international standard as shown below, and these are the international standard, and this is the implementation part. And now implementation part is going to explain my teammate Seeman Narayana.
Okay, this is Sriman Narayana. Use case diagram, class diagram, activity diagram, sequence diagram, collaboration diagram, and layer diagram. And each in this architecture diagram, we taken from the input from the user. From the input from the user, it will go to the pre-processing. Pre-processing means in our CPU only inbuilt process will be works. In the feature enhancement, after that feature enhancement, it will go to project detection and we track, and it will shows as display output. For that architecture, this is the explanation what I have been given. And this is the CNN for the YOLO architecture. In the CNN, we can see that the convention layer for every step, for each and every step, it having max code layers for every conventional layers. For that, this is the explanation for that. In this has 24 conventional layers and the data flow diagram. This is the most important part of this YOLO structures. In this, importing data and clearing data and the feature enhancement neural network are the main roles for this data flow diagram. From this, the central tracking will give that output and to the user. This is the class diagram. This is the class diagram. In this class diagram, the actor and the system is the main sources. In that, the middle capture and pre-process and CNN process will be due in this class diagram. This is the explanation for this class diagram. And the class diagram, we have the detail given from the user to the centroid. And this is a sequential diagram. In sequential diagram, we given the main names as the user and input and preprocessor and detector and centroid tracker. From this user and input, we given a pre-processor images. From this, we have given some loops. In these loops, we given some frames. From the frames, we are bounding boxes, coordinators from the center. This helps to improve the accuracy and the consistency of the object tracking results. And next, activity diagram. In this activity diagram, based on the number of the frames present, the function calls is made. If the number of frames is 1, then it calls the image function. Otherwise, the number of frames is greater than 1, it represents the video and the function calls nodes. And next testing. In testing, we have been classified into some of types, some of the steps like unit testing, integration testing, functional testing, and white box testing, black box testing. In this unit testing, we entirely divide into functions and modules. We tested the independently from the given input. We have been taken this in unit testing. This is the code for the unit testing. What we get the results, it has been checked whether the information is properly following the program until the properly happened output or not from the interface testing. In this integration testing, mainly we are giving bottom up approach. Integration testing is a semantic technique for the concentrating the program structure while at the same time. And next, this is the input for the integration testing. What the result for the integration testing is here. The integration testing checks for the interface while tracking the file input from GUI that interacts in order to perform future object detection. And next, black box testing. Black box testing. In this black box testing can helps to ensure that the system is correctly identifying and localizing objects in image without replying or knowledge for how the system works internally. This checks the internal system how the works. It's right. It's working correct or wrong. This is the input for the black box code. Output, it has been checked successfully. The internal works of this input is correct. This is the input and the output design for the GUI making. This is the GUI. What we did in this GUI object detection, we given some parameters like image, video, and webcam. Now my teammate Rakesh will explain the implementation part.
This is Gunnar Rakesh. I will explain the implementation part from here. I'll show the implementation part. We used ID as a Visual Studios. This is our code. We used YOLO algorithm. Here the code. This code contains Python program that performs object detection using a pre-trained YOLO model. Displays the result on the screen, as allows the user to select the input file using a graphical user interface. The program first imports the several Python libraries, including random tinker CV2, OpenCV2, NumPy, and utilities. It then defines a function called OpenVideo that takes a file path as an argument and performs object detection on the frames of video file of a webcam stream, depending on the input. Inside the OpenVideo function, the program loads a text file, contains a list of object classes stored in Kogo.txt, and generates a random colors for each class, and then it then loads a pre-trained YOLO model from file using the utilities library and sets the desired width and height of frame to be processed. Next, the program captures the frame of the input video or web stream, resizes to desired dimensions. It then performs object detection on each frame using the YOLO model and draws bounding boxes around the detect objects using the previously generated colors. The program also displays the class name confidence score of each detected object near its bounding box. Finally, the program waits for the users to press the key to terminate the detect process, release the resources used to capture and displaying the video, and closes the window. The program also defines the function called OpenFile that creates a file dialog window using tinter file dialog that users select the video file uh, web frame and then calls the open video function from our system which we saved file as a input. The program is created with a 3 buttons labeled image, video, webcam, which we created in this as we used as a GUI method, which we shown in the PPT. Now we'll show the implementation part. We'll run the program now. The program is running now. This is the object detection GUI. From here, we will take the video now. Click on video. If you click on the video, it will ask for the input. You are taking the crowd sample input as a video. Now the input has taken with the code. Now it is running in the background. It will show the output. This is the bounding boxes. This is the car. This is the confidence level for this. This is the umbrella. It is showing here. It is umbrella. It is a car. It is a bus. And confidence level also it is showing for the person and umbrella. See, this is our output. Conclusion will conclude by the Sriman Narayana. This is one of the image input and outputs. Conclusion will conclude by the Sriman Narayana.
Okay, from this project, we have been learned that how the detecting the object in an accurate way by the using this YOLO algorithm. By this tracking is the important in our day-to-day life, from how we are taking the objects and giving to output. From heavy traffic also we can find these objects with an accurate way. From this project we have been updating the accuracy level and confidence levels of that object detection. This is a V5 algorithm in this way defining. Okay, thank you.